Okay, so we just did the quadratic formula a few times in the last example. We're going to do the quadratic formula again in this problem, but I didn't really talk about why the quadratic formula is nice. You guys have learned several ways how to solve quadratic equations. You learned how to solve with graphing, which, kind of gives you some estimates, not always the best option. We solved by factoring. Well, that's easy as long as the quadratic equation was factorable. You learned how to solve with square roots. That works if you only have one term with an x in it, if you have just an x squared. You learned how to complete the square, which takes standard form and puts it into something you can use to solve with square roots. And then the quadratic formula. Quadratic formula is really nice if you can't do any of the other methods. The other ones might be faster for certain equations, but if you can't use those other methods, then quadratic formula is kind of our fallback. So I'll kind of address that as we get into the details of this example. So example 2, the function shown represents the height of a frog x seconds after it jumps off the rock. How many seconds is the frog in the air before it lands on the ground? So when they ask for how many seconds, that means we're going to solve for x because x represents our time. And more specifically, they want to know how many seconds the frog is in the air before it lands on the ground. So when it lands on the ground, your y value will be 0. So we take our quadratic equation over here, quadratic formula. We're going to substitute in a 0 for the y. And now we have an equation we can solve. And this doesn't make any sense because it says x seconds, but we are in t's over here. So I'm just going to use x's. I don't like writing t's anyway. So negative 16 x squared plus 10x plus 0.75. Now, could we use any of the other methods to solve this? Well, factoring, no thank you. I mean, we have a 0.75 here. I'd have to use the grouping method with a term in front of the x squared. Could we complete the square? Well, that's kind of a pain with this negative 16 out front. Can we solve using square roots? Nope, not if you have an x squared and another term with an x. So quadratic formula really is the most appropriate method of solving for this. All right, so I'm just going to identify our a, b, and c just by writing a, b, and c above. And now we're going to plug those numbers into our quadratic formula. So again, x equals negative b, so negative 10 plus or minus the square root of b squared minus 4ac all over 2a. So I just plugged in the a, b, and c as I was writing it out. When we start simplifying, this negative 10 is just a negative 10. We didn't have the double negative on that one. So negative 10 plus or minus the square root of, now we're going to grab our calculators and type in this with all of those parentheses super accurately. Don't forget this little squared guy right here. When you do that, you get 148 all over negative 32 when we multiply that out. Next step, this negative 148. So normally we might try to reduce that. Can we reduce the radical? But when you guys have a word problem, decimals are okay. That is that's a good real life way to approach this. So we're going to type negative 148 into our calculators. I'm just going to rewrite negative 10 plus or minus. That gives us 12.17. All right, because the negative 10 and the 12.17 are like terms, we're going to split this up and continue on with our simplifying. First one will be negative 10 plus the 12.17, all divided by negative 32. When we do that, we will simplify the numerator. Negative 10 plus 12.17 is 2.17 divided by negative 32 gives us negative 0.14. So there's one of our solutions. The other one, we're going to do negative 10 minus 12.17 divided by negative 32. When we simplify that, we get a negative 22.17 over negative 32. That divides into a positive 1.39. So we have two solutions. We're used to getting two solutions in our quadratic equations. Visually, what we're finding are the two solutions where your parabola crosses the x-axis. So that negative 0.14, if this were to continue down here, that's on that side. The 1.39 is over here. Because we're representing time, the negative solution does not make sense. We don't measure time with negative numbers, so we don't want the negative 0.14. It's the 1.39. So the frog is in the air for 1.39 seconds. All right, follow-up question, as we often have. The height of another frog over time is modeled by the function y equals negative 16t squared plus 10t plus 0.3. So they changed that c value. The c value in the first equation was a 0.75, and right here it's a 0.3. What that means is this frog is leaping from a lower spot. They're closer to the ground. They're not as high up. How many seconds, so solve for x, is this frog in the air before landing on the ground? That's when y equals 0. Round your answer to the nearest hundredth. Okay, so we take our equation. We're going to plug in a 0 for y. That's when we're on the ground. Your height is 0. Negative 16, I'm going to use x's. X squared plus 10x plus 0.3. All right, we start by identifying our a, b, and c values. We plug into our quadratic formula. X equals negative b, so negative, plug in your b value 10, plus or minus the square root of b squared, so 10 squared, minus 4ac, so 4 times negative 16 times 0.3, all over 2a. All right, so that negative 10 is just negative 10 plus or minus the square root of. Grab your calculator, type in 10 squared minus 4, parentheses, blah, 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 all of that. Type it in exactly as you see it. When you do that, you get 119.2, all over negative 32. Next step, let's actually take that square root to see what we get. That gives us negative 10 plus or minus. The square root of 119.2 is 10.92, all over negative 32. Can we keep simplifying? If this 10 and the value we got from square rooting are like terms, we do continue. Those are like terms, so let's break apart our positive and negative 10.92. So first we're going to do negative 10 plus 10.92 divided by negative 32. That's going to get us a 0.92 over negative 32, which divides into a negative 0.03. Now let's do negative 10 minus 10.92 all over negative 32. When we subtract that, we get a negative 20.92 divided by negative 32 gives us a positive 0.65. All right, both of these answers are representing time. The negative solution does not make sense. We're going to use the positive one. So the second frog is in the air for 0.65 seconds. And that kind of makes sense. This second frog started lower and they landed on the ground sooner, after 0.5 seconds, than the first frog that started at a higher height.